These are the flat plate solar collectors. You can see all connected in series. For example, here you can see that solar collector series, then series, for example, here water will flow and then it will go through this one and then the water is out like
This
that.
output.
This is output. From here the input, one solar collector, the output of one is the input of the other.
Yes.
Water will go from 1, 2, 3, 4 in series.
Yes.
And the inlet of the point will have the less temperature of the water, and here you will see the maximum hot water you can get here, okay. And then this water will be injected to the evacuated tube. This efficiency of the evacuated tube is more than this flat plate, and that parabolic is more than this evacuated, okay. So then the output of this hot water that is injected into the input of this evacuated, and then again are connected in series, you can see. And these points are connected here. You can see, you can find the temperature, different sensors at different points you can connect just to observe the temperature. And you can see there also with the tanks, there are different sensors, just temperature sensors, okay.
This will save the water, the hot of water.
Yeah, this is the
this
storage tank. Yeah. So this water you can store from the in the storage tank, and then there is a pump. You can see here. Let me show you, please. So here you can see there is a storage tank, and there is a temperature sensor. You can measure the temperature. For example, here there is a temperature sensor, and here if you will come here, so here is also the temperature sensor pipe. For example, here T3 and T2 like that. So you can this is the inlet water or outlet water. Temperature will be different depending on the flow of the water, okay. And here is the water pump, and this is the expansion tank. If there is the for example very hot water, no expansion point, then this point will beep horn or you say alarm. This will, and also expansion, extra heat will be injected here. Just this is for emergency.
Yes.
So it means emergency alarm will be here.
Yes.
So, and there is a water pump. For example, if solar intensity is low, for example in the morning or in winter, so you can see here there is a different points of water pump. Now it is fixed at 0.3. 3 mean 49 watt, and 2 mean 43 watt, and 1 mean 36 watt. Okay, so if 49, now it is adjusted 49. If hot water, very hot summer day, so you can change the wattage. If wattage increases, it will flow will be quick flow, fast flow, okay. So it means because water is quickly heating up, so you need fast flow, okay. So otherwise in winter you can slow down it, so that the hot water you can get depending on the required temperature what you need, you can change the speed of the pump, okay. So in this way you can see that different points. And you also, for example, here you can see different evacuated tubes. You can see this is broken, and this is the outside, and this is the black side which we were discussing, the second part. This is the first part, then second part, and inside is there is a copper rod which is and alcohol. Yeah, because alcohol is at low temperature it will vaporize, and the copper rod inside will this is the condenser bulb. You can see this is the condenser bulb, and water only flow in this condenser bulb. Okay. Heat will be collected here, and it will be injected in the inside this copper rod, and that copper rod, when alcohol vaporize, that pressure will push that copper rod, the head of the copper rod will be pushed into the condenser bulb. Okay. And heat will be injected into the water will absorb that heat, and when that vapors will cool down, again that will become the liquid alcohol. It will come down, and due to gravity that copper rod will go back, slide back, and again
the process will be again.
Yeah.
When the water doesn't like
no, inside there is no water. The water is just flowing there, and they're going there, and all this heat, that copper head of the copper, there is all copper rod will collect all heat of here, and that all heat will be condensed at the head of the copper rod, okay. And that head will be injected here due to vapor pressure, and then when vapor will be again converted into liquid, then again due to gravity copper rod will be slide down, then like that, this movement like that, so that heat will be absorbed here, and then that hot water will go there. And you can see here this is 30 tubes, 1 2 3 4 5 6 and 30. These 30 evacuated tube, evacuated solar collector, this is based on 30 tubes. And here you can see 1 2 3 4 5 6 7 8 9 10 tube based evacuated tube collector, okay. And similarly you can see there that is 15, and the other one is The other one is
10, 10, 10, and
10,
20,
and that is I think so 20. So different types you can use. Okay, so it depends on. So do you have any question?
No, sir.
So this in this
The
way.
best one is the last one. Is this
Yeah,
one?
parabolic is the best one.
Okay.
Then this is the vacuum tube. It is efficiency. We already mentioned in the lecture that how many BTUs energy can you collect for the worst case scenario during the winter.
Yes.
December, for example, this month. So you can, that is very efficient in the cold weather. Maybe this is not efficient in cold weather.
Okay.
So that is also mostly these vacuum tube used. Okay. So any other question? Okay.